Good morning, everybody. I think we are not active. Some sound should come from your end. Good morning. Thank you. I think first of all, I will introduce myself. Can I go to next slide? Okay. Basically, I am working with Sobha developer as vice president, and I have done my engineering in civil engineering background, and did my masters in geotechnical. I am in the field for last 34 years, and in GCC for last 25 years. I was in Oman for last 22 years, and now in UAE for last 2 years with Sobha developers. We are developing 2 islands. One is Siniya Island, which is 23 million square feet. It's a virgin island. And second one is a Sobha downtown, which is a reclaimed land, and the shore of 11 kilometers we are developing. Okay. I am not going to all the details because it will take long time, because my slide is almost 64 slides. And I have got only 15 minutes. Okay. So this is my journey. I started with the Konkan Railway project in 1991, where it was a bridge and the railway connecting from Roha to Mangalore. After that, I started working with Reliance Engineering, which is a mega project including the oil and gas. Then from there, I came to GCC in 2002 and worked in Oman with Bhawan Engineering, Gulfar Engineering. Then I shifted to the ruler, Oman, as an advisor for the marine works and the geotechnical works. I was there with the ruler for almost 17 years. From there, I came to Sobha as a vice president. Now working in Sobha Siniya Island and downtown as a vice president for infrastructure. So what I am trying to cover here today is basically how the island is getting developed, because what are the major problems you are facing when you are developing an island. This island in Siniya, it is a naturally reclaimed, naturally land given by nature, and we are not touching any of the profile. What we are doing all the soil investigation, filling and soil improvement, and making a big township which consists of almost 7,000 apartments and 700 villas. The first phase will be delivered in 2008 end, and the entire phase of the 23 million square feet will be delivered by 2029. So what we are doing here first, we are doing a dredging of the entire area, because the entire area will be having some, there is a big marina which yachts around 374 boat, which is almost half of the Dubai marina, and we have got a full island. And what we are doing, we are dredging the channel and creating a marina for that, and dredged material is used for filling. That filling material, what we do before starting the filling, we go for the investigation work. Usually we go for borehole test, CPT test, then we go for the post CPT. Then what we do the different type of compaction. So here we are trying to cover what are the different type of compactions we have used in the Siniya Island. So basically the compaction was done to mitigate the liquefaction due to whenever there is an earthquake happening, what happened? The soil, all the soil particularly in UAE is sandy soil. So whenever there is an earthquake, what happened? There is a seismic action, and it acts as a boiling sand, and the entire thing collapses. So what we have to do, once we do the investigation, we found that there was a soil layer of around 8 meters down below the filling, which was having a liquefaction potential. So what we did the deep dynamic compaction. You use deep dynamic compaction, where the soil was improved up to 8 meter depth, and it was around 20-ton pounder coming from around 20 meter height, and we are compacting the soil up to 8 meter. Then after that we do the post CPT test, then we do the zone load test, then we do vibro compaction, and these are the methods that we usually use to do. I don't know how many of you are familiar of these methods. I think we are all geotechnical engineers. So I don't need to explain on details what are the techniques that we are using. Here we had the company called Swiss Boring was doing the soil improvement for us, and our geotechnical consultant was GTC, Dr. Imad. I think most of you may be familiar. And our marine consultant is MCA, and our infra consultant was RTC. So these are the site photos where we have done deep dynamic compaction, and some place we have gone for vibro compaction because there are some vibration which caused, there are some heritage building which was in 4000 AD built by the ancestors, so that building has to be restored. So we did some vibro compaction there, so that no vibration was transferred to the heritage building, and successfully we have completed that. So after that, we do the post-CPT test. In the post-CPT, what we do, we see that the entire 8-meter depth up to down is totally compacted. Up to the required 10 megapascal is the CPT value that we have to attain. And we do the zone load test, which is basically, I think some fonts, we will come to that. The zone load test is, we do the zone load test to ensure that the safe bearing capacity of 150 kilonewton per meter square is reached at the founding level of the foundation for the villas. And the piling, we are going up to 35 to 40 meter piling for the multi-storied building. And all the liquefaction potential has been mitigated by soil improvement techniques. So these are the different methods that we use: pre-CPT, ground improvement, zone load test, then the post-CPT. Then we go for the authority sign-off before we start all the work. Now these are the parameters that we are meeting when we are doing the soil improvement techniques. This is a zone load test we have carried out, and the post-CPT test being carried out. This is the actual site photographs. I am not going into the engineering details. If anybody wants any further clarification, you can contact me anytime. I'll be ready to help you. As I told earlier, when we did the investigation, we had a liquefaction potential at around 6-meter depth. There was a very loose soil with some cavities, and we did some MASW. I think you know what is MASW. It's a surface wave test we do to find whether there is any voids below. And we found that there are some voids, so we have mitigated all the drawbacks, and we have improved it properly, and all the liquefaction potential was mitigated, and we have completed all the works. Now we have started the villa works, we have started, the piling has started, and now we are on the superstructure stage. Now these are the different type of, if we are not doing a proper investigation, what happens? Some mitigation measures are very expensive. So usually what we do mistakes, small developers, they don't go for the foolproof investigation. They directly go for the some minor SPT test, borehole test, and they go for the, sometimes they find some unequal settlement, the building get tilting, some problems, because the entire it is sitting on an island. The entire building may stand, but the entire road and may settle down if there is earthquake potential. So these are the case study what we have done, and I already explained the pounder drop and the vibro compaction method. I am not going into much details. The rapid impact compaction is required when we are the degree of compaction is only 3 to 4 meter in rapid dynamic compaction. After doing the road work, what we do, because after the compaction is done, we fill up to 3-4 meters for the road embankment with the dredge material, and we go for rapid impact compaction. And here I am going to tell how, because this is a marine and geotechnical interface. Here this is a total reclaimed, we are reclaiming the soil from dredging, and there is a total exposed to the sea, and there is a flushing happening inside the entire the entire scenario, the entire island. Water is coming inside and going. I think some of you may be familiar with marine, because basically we are having two high tide and two low tide. What happens during high tide, the water enter inside the island, and low tide it goes out. If the flushing is not happening properly, what happens, the island will not be, all the water will get stagnant, and there will be some foul smelling coming. So we have done hydrodynamic model, flushing model, and did the entire study for this, and we have found, and we are making a channels and culverts so that it is correctly exchanging all the water. Every 4 hours, 5 hours, the water is getting exchanged, and seawater is going and coming inside. So I'm just trying to tell that what are the studies we do, because now I'm going little bit into the marine side, even though we are talking about geotechnical. We do hydrodynamic model, metocean study, wave transformation model, flushing study, bed shear stress, and flood inundation. This is the right side. You can see the island which we are developing and how the flushing is happening during high tide and low tide. It is used as a mathematical modeling using the software called Telemac 2D. And this is the key wall what we have made. And there are different type of structures we are using, like breakwaters, key wall, groins, revetment, beaches, jetties, and marinas. This is actual photographs of the left side. You can see the key wall which is already constructed, which is almost 3.4 kilometer, constructed of concrete gravity blocks, and we are having an entire marina going to be built over there. So in another 2 years, you can experience the marina. The people can come inside. It is near to the Marjan Island where the casino is coming. So from Marjan Island, it is just around 15 minutes by boat. So it will be a next Dubai for the UAE, our development in Siniya Island. We have done the bathymetric study to ensure that all the works has been done properly, and after the dredging, we do the post-bathymetric study. Here I am going to tell how a coastal structure has failed due to improper engineering. Okay, in a coastal structure, mainly there are so many elements what we call. If it is a breakwater, we call the core locks, which is the outer layer. Then we have got the under armor layer. Then we have got the core material. That is how the wave energy comes and hits a structure. The energy is being dissipated at different levels. The outer structure will be like core locks, which are bigger structures, and it will dissipate the energy to its level. It transfers to the under armor layer. It hits the under armor layer. By the time the energy is zero, and the core will be safe. I'm just going to explain where a structure has failed due to improper engineering. It was in Oman. These are the different core units we are using for the outer layer, like acropods, ecopods, core locks. How many more minutes I got, please? It's not showing any time. Just give me some hint how much time I got, so that I can. How many more minutes? 5 minutes. Okay, thank you. You know, if you are aware of that, there was a Gonu which hit in 2006 in Muscat. Okay, in that time, what happened? We have designed the entire coastal protection up to case A and B, but what actually happened in Gonu, it was not as per the design. So sometimes what we have to see 1 in 100 return period, what are the past histories. Now after this Gonu happened in 2008, we have redefined the benchmark for designing all the coastal structures. This is, you can see the right side photo where the Gonu started. It hit the Muscat mainland, and you can see lot of structures was failed. The road was washed out. The entire area was flooded with water. You will not even imagine 7 to 8 meter water got flooded, and some of the Toyota showrooms was washed off. So I'm just going to one of the structure which failed, which was in Oman, Muscat. Earlier structure was designed as a revetment structure, which is having, shed units on outer side. Can I have a pointer? Pointer is there? Okay. Left side is a structure which was failed, and right side is a structure what we have did the re-engineering. Initial structure was having a filter layer, which was a shed unit, and below that we had a under armor layer. And what actually happened, the under armor layer, even though it is written under armor layer, at physically side it was not there. So directly what they have done, they put the shed units on the core material, and when the GONU hit, the entire structure got failed, and it collapsed and fell down, and the entire, the major rulers palace itself was flooded. So I was appointed as one of the consultant, and I did the engineering with company from UK, and we did it. You can see the physical wave flume model we have done, and we suggested to go for a concrete acropod armor unit, which is 16 meter cube, 40 ton as the outer layer. Then we have got under armor rock, which is 2 to 4 ton. Then the filter media and the scour protection at the top. So I'm just showing the structure. What we did, there was a initial structure you can see below, which was failed. On top of that, what we did, without disturbing much, we made the entire structure, which is around 1,000 meter length. We went for acropod units and under armor layer, and the existing structure was sacrificial. And we did this work in 6 months' time, in record time, and it was restored in 2008, and still it is standing. So this structure was failed 3 times. Why I am trying to tell that it is a poor engineering done. We have neglected the geotechnical part when we are doing a coastal structure. So I am just trying to how a coastal structure interact with the marine structure and with the geotechnical parameters. I am just going through the site photograph, how it failed. Such a huge structure, 40 tons. Overtopping and going into the sea, you can imagine the wave energy. So how it has failed and how it has reclaimed, and this is the final structure, how we have built. I am just going through the sequence, how it was built. Okay. So I am just going through the photographs, how we have done the dredging and did the, and this is a core lock units of 16 meter cube, 40 tons each. It was placed, the CLI was the agency who has supplied this engineering done for the core lock, and it was placed using a crane. After completion, this is how the structure looks.